All right, welcome back to another class for Math 7, another lesson, not class, another lesson for Math 7, lesson 116. So after today, 4 more lessons and that's it. But today's lesson is probably one of the hardest ones in Math 7. However, you should already know most of it because today we're going to talk about the slope-intercept form of a line. However, we already talked about the hardest part, which is slope. So please, you have to know slope very well for you to be able to then be able to find the Y-intercept. Because it's pretty easy. The Y-intercept is actually one of the easiest things ever. I'm going to explain how that is. And so let's get into today's lesson, which is going to be super important for Math 8 and especially for Algebra 1. You need to know this, the lesson for Algebra 1. Okay, so this is the introduction to the lesson itself. And so we have a line, right? I have 2 points on the line, and I drew them, and then I drew the line, and this is the line that they show you. And then they show you this 3 equations. Why equations? Because equations mean that they have an equal sign. That's what an equation literally is. And so they have 3 equations. And so they tell you these are 3 equations that actually are the same for this line. So they tell you that this is an equation that if you graph it, you will be able to find this line. How do you graph it? Well, you're supposed to do a table, right? So you're supposed to do a table for each one of those equations and then get 2 points. And then obviously you can just graph it with at least 2 points. So do 2 points per equation, and then you get it. So this is what we're talking about. The slope-intercept form of a line is this. It's a line, right? And these are the addresses, meaning this is how we get here. Let's think of the line as a location, a house, a place, all right? And let's think about this as the address to that house. How do I get to this house, to this line? By knowing the address, obviously. And the GPS would definitely be the table. Table would be a very useful GPS that would tell us where the line would actually be. So that would be the way that I want you to think about it, and it's super important. So before we talked about the slope, right? Previous lesson, I think lesson 112 or something like that. I'm not sure. I don't really recall. But before we talked about slope, and slope has to do with how steep the line is going. And remember, we read the line from left to right, from left to right. So from left to right, how is this line going? How is the slope showing? Well, the slope is showing by going from up here to down here. So it's going down, okay? So the slope is going down. So every time the slope is going down, we know it's negative. That's why we know that the slope here is negative. And so that's one of the reasons that I'm telling you the most important part of it is the slope. And so I just want you to remember a couple things about slope. The first thing that I want you to remember about slope is that I said it was going to be delta y over delta x. Delta means change, which is just a fancy word for difference. For those of you who are just seeing delta for the first time, delta is a Greek letter that signifies change. The change in y over the change in x. Change in y is the vertical change, the up and down change over the horizontal change. Okay, so how did I change here? Well, from this point to this point, how much did I move up or down? I moved 2 down, right? I moved 2 down. And how much did I move here? Horizontally, from side to side. I moved to the right, right? So to the right is positive. And how much did I move by? Well, this is 0 and this is 1. So I moved 1. That's why my slope is -2. It makes perfect sense, right? So the change in y over the change in x, or the difference in y over the difference in x, means how did it change, right? How did it go up or did it go down? Did it go left or did it go right? And we saw that it went down 2 and 1 to the right. And we got -2. All right? So that's why we know that this right here is our slope, -2. Okay. Yeah, let's not include the x. Actually, let's just leave it here. So we have -2. Okay, that's cool. So we have -2, but then we have this number here. This is weird. Well, the one thing that I want you to know is that this right here, the third one that we showed you, this is called the slope-intercept form of a line. It's called the slope-intercept form. Okay, so now that we actually have identified which one looks like the slope-intercept form, let's actually talk about the slope-intercept form of a line. Okay, so I said that this was the slope-intercept form of a line, and then I wrote this right here, which is literally what it should be. It's called like that, and so from now on, whenever I say M, you have to know that it's called the slope. This is the slope. And this is an intercept, but what type of intercept is going to be the Y-intercept? That's what it's called, the slope-intercept form of a line, right? So this is the important equation that we have here. And this one is this looks like that, right? It looks very much like that. So we know that M is going to be, the slope is going to be whatever is before x. So this is the slope. Now understand something. This is called a function because it's the relationship between two variables. What two variables? X and Y. X and Y are two variables, and there is a relationship between them that tells us that it's a line, straight line. And we know that in this particular case, it's a line that is going down. And so that's the slope. And this right here is the Y-intercept. Now this is the part that I think I have to explain more because it's the part that you mostly don't know what it is. So if I draw a coordinate plane, this is my x-axis, this is my y-axis. The y-intercept only deals with the y-axis, right? I don't really care here about the x. For the y-intercept, not for the whole thing, but only for the y-intercept, I don't care about the x-axis. So if it goes up, or if it goes down, even if it's level, we have to understand something. This 3 points right here on these 3 lines, it's where the lines themselves cross or intersect the y-intercept. The y-axis, I mean. Yes? It makes sense, right? So that's not very hard, but my question is, okay, so in respect to 0, this is a point, right? There's a point, there's a point, there's a point. 3 points on the y-axis. All points have 2 coordinates, right? So a point has the x-coordinate and the y-coordinate. It makes sense, right? So x, left and right, y could go up or down. That you should know by now. But in this particular case, are we going right or left? For the 3 points here, all of them are going to have an x of 0. Oh, okay. And then whatever it is. For example, if I say that this is -2, this would be -2. If I say that this is a 2, this would be 2. And if I say this is a 6, this would be a 6. So for example, point here would be 0, -2. Another point would be 0, 2. And the last point would be 0, 6. It makes sense, right? So one of the things that I want you to understand is that all of them, all y-intercepts will have an x value of 0. That's why we don't care about the x value in my y-intercept, because I already know that all of them are 0. So what it's telling me here, particularly in this instance, is that I already have a point, 0, 4. So why is this slope-intercept so interesting to us? It's really interesting because anytime we have a line in the slope-intercept form of a line, we automatically get 1 point. They literally give it to us. How? The y-intercept point. They already gave it to us. In here, they said that it would cross the y-axis at 4. So the length of 4, 3, 4, 5. So here, 4. and it has a x value of 0. So my point is 0, 4. So that's why it's really interesting for us to know that the y-intercept is the easiest thing ever. And whenever we have a slope-intercept form of a line for an equation, it tells us already 1 point. So how many points do you need to graph? You need 2 points. So you're already ahead by 1. So you just have to find another point, and then you can find your line, right? So that's one of the reasons that we think that this is really important, and it's actually really important. So yeah, that's the explanation behind the slope-intercept form of a line. Hopefully everybody understands slope. Slope, as I said before, M, is, according to your book, which I don't like at all, is rise over run, but I don't like that. But I like that more, delta y over delta x. Delta, change, or the difference in y over the difference in x. Now there's another formula that I teach everybody. y2 minus y1 over x2 minus x1, where this is 0.1 and this is 0.2, because for a line you need 2 points, and for a slope you also need to find 2 points. So it's not that hard. Okay, so let's see the type of problems that you have to do with this information that I just gave you. Okay, so here we go. We have the slope-intercept form of a line, and then we have the problem in example 1. And they ask us, okay, put this equation right here into slope-intercept form of a line. Okay, so a lot of you are going to be like, wow, this is super hard, but it isn't. The key is understanding this, and this is the key. Solve, meaning leave by itself, for y. Because y is by itself here. Y equals. So if I solve for y, I'm done. That's all I have to do. And so if I do that, I have my problem 3x plus 6, plus y, I mean, equals 6. And then I'm going to subtract 3x from both sides. Why? Because what is the 3x doing to the y? The 3x is adding to the y. So I have to do the opposite, subtract. So I'm going to subtract 3x on both sides. And then I'm going to get 0 here. And then y equals 6 minus 3x. It kind of looks similar, but it's not the same. I have to put my term with the x, the term with the x, I have to move it to the front and then put my whole number in the back. So it's going to be y equals, or not whole number, but integer. It's supposed to be an integer. For the most part for you guys. 3x plus 6. It could actually be an irrational number as well. But I'm not going to say that. Okay, so y equals negative 3x plus 6. And that's how I did it. So was it very hard? No. And as you can see, I have a number before the x, and then I have another number. This is exactly what I need. I need the slope, and then I need the y-intercept. By the way, the slope is, do I have to recognize the slope and the y-intercept? No, but I'm going to actually do it because I think it's really good practice. So the slope is negative 3. The y-intercept is not just 6. 6 is just one number. I need the point. The point is 0, 6. So negative 3 and 0, 6. That's what I need to do. All right. So I hope that this wasn't too hard. I mean, it shouldn't have been too hard. Let's move on then to the other example that we have. Okay, so this is what we used in example 1. The same problem, but solved for y. So now we have y equals negative 3x plus 6. The slope is negative 3. The y-intercept is 0.6. And now I can graph 1 point. Not the line, but 1 point, right? So 1, 2, 3, 4, 5, 6. That is going to be my y-intercept, my y-axis, my x-axis. Okay, so I have 1 point, 0, 6. Yay, 1 point. But now I have to find the rest. Okay, so what should I do? Let's see here. Why don't we just use the slope? Or I'm going to show you 2 ways, okay? The easiest way and then the other way. So forget the slope. Let's actually do the easiest way, which is a table. literally the table would be so easy. Why? Because I already know 0, 6, right? That was given to me. X is 0, y is 6. Now let's put a 1. Remember, for a table, you can choose whatever number you want for x and then find the y for that x. It's pretty easy. So what you need to do is put this 1 right here instead of x. That's literally all you have to do. Instead of putting this x here in this equation, you put a 1. Because that's what you say. I want x to be 1. So let's say, okay, then let's put a 1 here. So negative 3 times 1 is negative 3. Negative 3 plus 6, it is not going to be negative 9. It's going to be positive 3. How come? Because 6 minus 3 is 3. So 1, 3. So 1, 6, 5, 4, 3. So we have 1, 3, and 0, 6. Okay? Look at that. I have 2 points. If I want a third point, I could do it. 2, so I put a 2 right here. What is negative 3 times 2? Is 6. Is negative 6, sorry. Negative 6, okay? So negative 3 times 2 is negative 6, and negative 6 plus 6 is 0. Look at that. Two, 0. I have 3 points, and I could keep going, and this is the easiest way to do it. To literally do a table, okay? You need to know how to do it with a slope. No, but I'm going to show you anyway. Okay, so the slope, remember, the slope is going to be delta y over delta x. Change your difference, okay? The difference in y over the difference in x. Now, in here, you're going to tell me, but how could it be a fraction if it's negative 3? Well, because the difference could be negative 3 over 1. And I'm going to put positive 1. Why positive? Because negative and positive is negative, right? And that's what I got, negative 3. So then what I do is this. I get a point, 0.6, or 0.06, I mean. And I say in y, I have to go down 3. Because it's, what is 6 minus 3? 6 minus 3 is 3. And I'm going to go 1 to the right because it's positive. Oh, okay. So 1, 3. Oh, wow. That's what I got. Okay. Let's try it again. So I have 1, 3. And 3 minus 3 is 0. And 1 plus 1 is 2. Oh, wow. Look at that. So that's how you do it as well. It's pretty easy, but I would recommend you guys use the table. It's easier, but both ways work. And now, obviously, those are points that's not a line. Now I have to draw my line. So I take out my pocket ruler and I draw my line. Booyah! Woo! All right, example 2 is done. All right, in example 3, we have the same question as in example 2, but it's a different equation altogether. So they say, okay, why don't you just graph that? Okay, so the first thing I'm going to do is I'm going to say, okay, my slope and my y-intercept. My y-intercept is going to be 0, negative 2, because it's a negative 2 right here, right? Pretty easy. Now, slope. What is my slope? My slope is the number in front of my x. X is a variable. Now remember, I told you when I was telling you about polynomials that all variables have 2 things. The first one is an exponent, and the second one, actually it's the other way around. The first one is a coefficient. All variables have this beautiful word that is called a coefficient, okay? So a coefficient, and the second thing it has is an exponent. All variables have a coefficient and an exponent. Okay, but so what is the coefficient here? Because I can't see it, the coefficient is 1. Positive 1. Oh, okay. So now I have my slope. I have a point. So I do have a point that I can put down in my graph. Zero, negative 2. And then I have a table in which I could put, so I'm going to put a 1 because I think 1 is pretty easy. So 1, I'm going to put a 1 here instead of the x. So what is 1 minus 2? 1 minus 2 is 1, negative 1. And then I'm going to put a 2. 2 minus 2 is 0. Okay, look at that. I already found 2 points as well. So negative 1, 1. I mean 1, negative 1, sorry. Whew. And the other one is 2, 0. I found the point again. Again, you can actually use the slope. And again, one of the reasons I think people find the slope harder is because all the time we've been telling you first x and then y. First x and then y. When we're talking about graphing, even the points, you do first the x and then the y. In the table, you do first the x and then the y. But in the slope, we're telling you, wait a second. We have to actually put the y in first and then the x. Which is, I mean, that's the way it works. But it's okay. So, if we do that, because the slope is 1, it's going to be 1 over 1. And it's going to be positive, positive. So, if I start with this point 0, 2, I'm going to add negative 2 plus 1 is negative 1. And 0 plus 1 is 1. 1, negative 1. Oh, look at that. Then again, I'm going to add, from this point, 1, negative 1, 1, negative 1. I'm going to add 1 to the y. What is 1 minus 1? 0. And then 1 plus 1 is 2. Boom, 2. So then I graph. Again, pocket ruler. Came out of nowhere. Yay, pocket ruler for the win. And that's the line. Yay! That's example number 3. Let's move on to example 4. All right, so the last example made me do a double take and everything because it made no sense when I first read it. And the diagram doesn't make any sense because they put Robert to be about 8 feet tall. That's not true. Robert is not the tallest man in the world. So what happened was that I made this beautiful diagram, and I know for a second there you got confused. You're like, whoa, is this art class? No, it's still math. So I drew this house, beautiful house, by the way. I know a lot of you would love to live here when you grow up. And then we have a tree, beautiful tree. It's like more like a pine. In there they had some other type, like, I'm not very good. I'm not a botanist. You can ask Pastor Pratt what type of tree that was. Not really into botany. Yeah, so we have this guy, Robert, and he was looking up. I don't know how he perfectly lined up his eyesight so he would look right through his, like, across his roof and see the nest. But that's what it says in the problem. Anyway, they say that the house is 8 feet tall and that it's not a very tall house either. Just think about people being 6 foot tall easily in school. It's just 2 feet higher than that. Is each floor 4 feet? Or is it just a one-level house? If it was a one-level house, I would think it probably is a one-level house. I think I'm overthinking this. Anyway, so, yeah, we have the nest, we have the tree. It's 48 feet away from Robert. And then they tell you, well, how tall is the nest? So meaning, how tall is the tree altogether? So there's several things that you have to understand why I don't think this is a good problem for this particular lesson. They're trying way too hard, first of all. And second of all, you don't even know where the x-axis would begin. Most people would actually think, oh, the x-axis begins right here with Robert. But it doesn't. The 48 feet starts right here with the house. It doesn't start with Robert, it starts with the house. Now, if this is 8 feet, this is also 8 feet. Okay, so that's important because then what they're trying to tell you is like, okay, you have to build kind of like the graph with a y here, the x here, and you're going to go all the way to 48. We want you to know what 48 it is. Start at 0, and it will start at 8. Okay, each one of these is going to be 4 in my graph. So it's 4, 8, 12, 16, 20, 24, 26, and so forth, right? So we can label it 4, 12. Hi, come on, Ming. The 12 doesn't want to come out. There we go, 12. 16, not 14. 16, 20, 24, 28, and so forth. Yay! So you're supposed to do that. Now, they tell you something really weird too, that the roof is 4 and 8. Again, what does that mean? I don't know. It's so weird. That's why I think it's so dumb. It's 4 and 12, I mean. Not 4 and 8. 4 and 12. Apparently what that means is that you're supposed to know that this is 4 feet high by 4 feet 12. By 12 feet long. Just one side of the roof. So that's kind of weird. And so you're supposed to set it up 4 over 12, which is the same thing as 1/3. And this is supposed to be by slope. So I have y equals 1/3 of x. Yeah, my board moves towards the bottom because it's not nailed down, so I have to press it against the wall. But it's not really my board. I borrowed it, so I can't do that. So y equals 1/3 x, and then the y-intercept is supposed to be 8. Why 8? Because that's how tall the house is. So you see what I mean? It's just so weird because it's not something that you would actually get normally. You have to kind of like really work at it and understand what they're trying to tell you, which I don't think it's the best way to do it. Anyway, the actual way to find how tall the tree is to do a table. I think it's the easiest way. So you're supposed to put the x and a y for the table. I already know that 0 is going to be 8, but then I'm going to put 48. So I'm going to put a 48 there instead of an x. And so it's 1/3 of 48. 1/3 of 48, I believe it's 16. Yes, it is 16. And 16 plus 8 is going to be 24. The nest is 24 feet high. And that's the line that you're supposed to draw. Yeah, again, I apologize. I don't really write your book. I have to teach your book, but I don't really write it. And I don't agree with this problem at all. I don't think it's helpful to the lesson itself. I don't think it's something that is going to give you confidence in it being able to solve problems. But you just have to be careful about the way you book. About the way the book words things. And this is the problem. All right. So that's it for lesson 116, which is the harder of the lessons that we had left. So we'll see you guys in the next one. Okay. 4 more to go.